So, GPS provides the fastest and most accurate method for mariners to navigate, measure speeds, and determine location. It is important in marine navigation for the ship officer to know the vessel position while in open sea and also in congested harbors and waterways. A gyrocompass is a form of gyroscopes used widely on ships employing an electrically powered, fast-spinning gyroscope wheel and frictional force among others factors, utilizing the basic physical laws, influences of gravity and the Earth rotation to find the true north. Marine radars are X-bands or S-bands radars on ships, used to detect other ships and land obstacles, to provide bearing and distance for collision avoidance and navigation at sea.
ARPA. Elements of ICDIS is the safety of navigation. ARPA is an automatic radar plotting aid is computerized additional features to the radar. ARPA takes feed of the own ship course and speed and target course and speed and calculates the collision avoidance data and simplifies the needs for the users to calculate the data themselves. EcoSounder. EcoSounder measures the depth of water by measuring the time for a pulse of energy to travel to the sea bed and back and work on the principle of reflections of acoustic energy. Short pulse of sound energy is transmitted vertically down from the ship. Familiarization of the setting up of ICDIS. ICDIS has become the essential tool for watchkeeping officers on ship. Navigating a ship with an ICDIS is fundamentally different from navigating with paper charts. It is important that the masters, navigating officers, and ship owners are aware of the benefits of managing the chart deeply. Safety settings and alarm system of ICDIS. ICDIS is equipped vessel has been involved in a number of groundings which may have been avoided had it not been for failure in the setup and use of ICDIS safety. Settings and alarm system. Inappropriate settings are likely to render the safety contour alarm meaningless.
These values can be entered in Furuno ICDIS by following steps mentioned below. Go to main menu and select chart display. Select the main tab to display it. Safety contour. The safety contour is the most important parameter of all the safety settings for the display of unsafe water areas, detecting isolated danger and triaging anti-grounding alarms. The safety contour is basically an outline which marks the division between safe and unsafe waters. The color blue is used to indicate the unsafe areas while white or gray for safe areas. The default safety contour, if not specified by the mariner, is set to 30 meter. The blue color is traditional paper chart does not provide a vivid picture of shallow water. The depths mentioned in the blue part of a paper chart may be shallower for a deep draft vessel, say for a vessel with a smaller draft. If within a specified time set by user, the ship is about to cross the safety contour, an alarm will sound. Based on the value of safety contour, ICDIS display the isolated danger symbol for underwater features and obstructions which may pose a danger to navigation. The isolated danger symbol is a display if an underwater feature like wrecks, rocks, or other obstructions has depth less than the safety contour in waters beyond the safety contour.
Safety depth settings. The safety depth's only function is to display spot sounding in gray for deeper depths and black for shallower depths in comparison to the safety depths value entered by the navigating officer, showing the possible safe and hazardous location. Alarms or any other features of ECDIS are unaffected by the safety depth settings. And there's a chance that depths less than the safety depths occur at the same point in the navigable waterways. This risk will subsequently be highlighted by the safety depth settings. What is safety depth? The illustration below show an example for safety depths. The safety depth's primary purpose is to display sounding in gray for greater depths and black for shallower depths. Shallow contour. The shallow contour emphasizes the gradient of the seafloor. It is regarded as the grounding depth. In other words, the depth below which the ship will certainly run aground.
So this also gives the options of simple two-color shading. So in this situation, light blue and deep blue will merge into a single blue color, and gray and white will merge to a single white color. If the value of the safety contour is changed, the boundary between two deep shades change accordingly. Then two deep shades can be used during the night time with the caution reduced the contrast difference between adjacent areas. So as you can see, makita nato diri sa chart display diri sa kilid sa ICDIS. Na diri makita ang mga 4 shades, full light lines, contour, mga label. So if we click nato na mo gawas na diri sa screen sa ICDIS. So klase-klase ang mga colors, numbers, ano mga number nag-specify sa gilawmon sa tubig. Next ang daytime and nighttime. So makita nato ang difference between daytime o nighttime kay ang sa daytime maklaro gud siya nga puti gud siya. If i-set nato siya nighttime, so murag mo mabutang po siya night mode, mo black yang color sa screen sa ICDIS.
Watch vector or anti-grounding function. The look ahead or watch vector actually confers the safety settings that have been entered by the navigating officer with the deep information contained in the ANC, and generates an indication or warning where the safety settings will be contravened. It provides advanced warning of dangers or cautions, primarily intended to prevent grounding. It acts as a final layer or safety should a navigational danger be missed by the visual check or route scan. The scan area is sometimes displayed as a cone or column on water ahead of the vessel. This value should be determined for each stage of the voyage and noted in the passage plan. Many officers fail to realize the significance of the safety contour and do not make proper use of the look ahead vector. This is you can activate on ship check-in for Rono ICDIS. Go to chart menu and select initial settings. And open the menu displayed at the left and choose chart alert parameters.
So next is to click the check area tab, and it is located here at the
So the data displayed in lower status bar includes the following: the UTC time, local time zone, mode of workstation, scale, software release, and alarms. So in UTC time, it is the coordinated universal time, or it is the indicates the time on the Greenwich meridian. So next, the local time zone, or the user can select local time zone to be displayed in this field. And next, the mode of workstation is indicated with text multi, single, plan, or slave. Next, the scale of displayed chart is shown in this field. And the software release is the current software, or the upper value is software release of the ECDIS chart, or the lower value is software release of the ECDIS navigational interface. Next, the alarm, or which is the alarm generated by the system and by the steering, is shown in lower status bar. So next, the information area. So in the information area, where is permanently displayed information about the position of the on-ship and the route monitoring, and also the information of cursor's location on the chart. So the information from the positioning sensors are the following: the latitude and longitude, which as you can see is here at the right side of the screen. It has 59 degrees and 51.5 minutes north, and 24 degrees and 28 minutes east. Also, we have also the gyro readings beside the latitude and longitude, and the COG and the SOG, or the course over ground and speed over ground. Also, in the information area, we can find also the positioning source, which can be the reckoning, GPS, or the DGPS. And next, another information from route monitoring. So, ano siya makita nga information if mag-monitor ta sa atong mga ruta. So, ano ito makita da kaya atong land speed or ang kusgon sa atong dagan sa pag-approach sa sunod nga waypoint.